Hello guys, how is it going? Let me check if you can hear me. Okay. How is it going, guys? How was the contest today? Let me come to my screen. How was today's contest? Hard. Let me also check Codeforces for a second. Okay, stream. The stream has started, so I can update this. I started the stream sooner this time, sooner than expected. So let's say 11:40. Let me also say that in the Telegram channel that the stream is started. Solution discussion. I'm live for solution discussion of educational round 175. Okay, solve till E. Super contest, I solved ABC hoping for pupil. I'm leaving CP because I can't handle being in teachers. Why? Felt like lead code contest. Need C. Yeah, we will solve C. I read problems A to E and we will solve problems A to E today. How many problems you guys solved? I'm at the same time waiting for more people to join because it's scheduled for 11:50. It might take some time for the rest of people to come, so it's good if we wait a little bit more. Problem C linear series solved A, B, D, A, B, 2, but I think I could have solved D. Oh, that's bad. I read the problems and I think they were relatively, compared to the previous educational rounds that I had in my mind, I was thinking that it's probably a bit easier, but I'm not sure. Based on what you guys are saying, it might have been harder. But what I got, I don't know, what do you think? Could do 2 only, C seemed doable, but couldn't figure it out. Solve A, B, C, D, but could have solved faster. Only A. Okay, I see. If you have solved B but you're stuck in A, I believe you should start implementing B. I mean, it's completely okay. That sometimes happen. I also had some contests like that B was solved but A wasn't. I'm doing only CP 3 months. Can one land a job or internship? 3 months is too small. Is not enough time to get very good. Although in my new video, as I guess you guys have seen this video, I told you that in 3 months I got from newbie to expert. But even expert is not enough. Getting to even expert is hard in 3 months, but it's good. I mean, why not giving yourself a little more time? Have you guys watched that video that I'm talking about? I guess you have all watched that already. So there's no point in that, but anyway, I will share this if anyone hasn't watched it. It's 32K, it has 32K views so far. That's very interesting. This video, from newbie to experts in 3 months. I basically recommend to you to do whatever I'm telling you there. And guys, also in my Telegram channel, I have put a vote for the next, for the course that we're gonna have on dynamic programming. I first put the vote that if I make a course, what do you want it to be about? And you chose DP, In my Telegram channel, I put votes on what do you want it to be about, what is the biggest challenge to face for learning DP, and how do you learn best. I had to vote myself too to see the results, so I also chose what I was thinking. But anyway, if you want, you can. I want all of you to vote about that, because I want to, basically I'm planning to make the best course possible for dynamic programming. So it's very, very important for me to have your input and use that. The channel name, I send you the link. The link to the channel is this. Let me pin that too, so that I don't send it again. I think I missed some of your messages. 1 year for CM, yeah. CM takes more. As you go further up, it gets harder. Something for beginners specific. For beginner, most of these guideline videos are for beginners, from newbie to expert in 3 months. Don't do these to get out of newbie, and do these things for getting out of newbie. All these guideline videos, let me send the link of this as well. All the guidelines are basically for beginners. And what do you think about Yusaku Guide? It's a very good source. Yusaku Guide. I really recommend it. So guys, don't forget to give me your inputs on this, on how you want the DP course to be. I want to seriously make the best course ever, something that we don't have right now and has some gap from every content that currently exists. Okay, I guess so many people have joined us, so maybe we are gradually getting ready to start the discussion. Okay. So, are you guys ready to talk about the problems? I think one of you asked some question that I wanted to answer, but I forgot what it was. That. Let me see the comments again. Let me change my screen. How much did it take to reach 1900, current rating 1000? First try to reach experts. I recommend to you to first try to reach experts. After this solution discussion, I recommend to you to watch those videos. I told you completely on what you should do. I told you completely what did I do myself that in 3 months I got to experts. And when it works for me, it definitely works for you as well. And it's not for me, also for all of my students. I have taught more than 300 students in the past years. And this is exactly what I tell everyone. Which webcam do you have? It is my Mac webcam, but it is damaged. It's clean, but it's a bit blurry because it's damaged. And that's really bad. Is the quality low? The quality of my webcam? And guys, also I will put the votes for the next topic stream in the Telegram channel as well very soon. What do you want to discuss in the next topic stream? Let's say that very quickly until more people are joining. It's getting 11:50 here EST time, so we should start soon. What do you want to talk about next time? Let me show that what we have covered so far. The last time, what was the last stream that we talked about? The last topic stream that we had was about greedy algorithms. And previously we have had dynamic programming, graph algorithms, number theory, combinatorics, etc. What do you want for the next one? How to get out of expert? Probably I can make a video after that about this. Segment tree. Greedy again. Binary search. I have a video about binary search. Guys, some of these things that you suggest I have already. Here are the topic streams. Almost never on Friday topic streams. This week also, because tomorrow is a contest, we won't have on tomorrow. We have dynamic programming, number theory, graph algorithms, binary search, game theory, combinatorics, diffy bit mask, trees, problem solving, and greedy algorithms. DP on trees, constructive, greedy, constructive, math. Yeah, I will put all of them in the votes, but you guys choose that which one talk in the next topic stream. Bit manipulation, math and geometry. Can we start up solving now? Yes, I think if you mean start solving the problems in the contest, yeah, you should do that. Gotta go dinner, we'll watch after it. Okay. Heavy implementation. It's night at your time. In here it's still, I haven't ate lunch yet. It's still before noon. Okay, good. Good. I got some idea about what you guys are looking for. So, shall we start talking about the problems? I guess everyone who wanted to join have joined by now. Can you do a lead code problem solving stream? Yes, I can also do that. A lead code problem solving stream is also a very good idea. That's also interesting. That's something new. If you guys like that, I can do that. Why math should be the first thing we should learn? I think that then others is midnight, Bangladesh. Yes. Cool, that's cool. It's before noon here. It's 11:53 a.m. Okay, so let's start discussing the problems today. The first problem, FizzBuzz Remixed. It says that FizzBuzz is one of the most well-known problems from coding interviews. In this problem, we will consider a remixed version of FizzBuzz. Basically, it's saying that given an integer n, for every integer from 0 to n, you have to count that how many of them are this, the remainders is the same, modulo 3 and modulo 5. Okay, so you are given some number n, and you have to say that from all of numbers from 0 to n, how many numbers have the same remainder modulo 3 and modulo 5. For example, if you are given 15, the numbers 0, 1, 2, and 15 have the same remainders on 3 and remainders after division by 3 and remainder after division by 5. So we basically, in this problem, we basically are looking for all the numbers like I, let's make it thicker. We are looking for all numbers like I from 1 from 0 to n such that I modulo 3 is equal to I modulo 5. Well, the first thing that I say is that I modulo 3 is basically equal to I modulo 15 modulo 3. I mean, when you want to see that what is a number modulo 3, you can first calculate that what is its modulo 15, and then for the results, see that what is that result modulo 3. Because by calculating modulo 15, it's like you are subtracting 15 times some k from it. Because 15 is divisible by 3, it's like you are subtracting 3 times 5k from it. So its remainder by 3 does not change. So I modulo 3, basically what I'm saying is that I modulo 3 is equal to I modulo 15 modulo 3. And it's true always. For example, for any number, I modulo d is equal to, always it's equal to I modulo sum k times d and then modulo d. This is always true. Because by calculating modulo kd, you won't change the remainder of the number modulo d by calculating it modulo kd. Okay, do you guys agree with this so far? Is it clear? I'm saying that I modulo d is always equal to I modulo sum k times d and then the results modulo d. So basically, if we agree with that, first, I want to make sure that you are all, it's clear for all of you. If it's not, tell me to repeat it again. If it's clear, please use this emoji or put a plus in the chat. If it's not, with the minus, or tell me that it is not clear. Not clear. Okay, I will repeat. So I'm saying that, sure. I'm saying that assume that we have some number, like consider that we have number 2. We want to see that what I modulo 2 is for some I. I'm saying that I modulo 2 is always equal to I modulo 10 modulo 2. So basically I'm saying that when you want to see that if a number is odd or even, you can just consider its least significant digits. Why is that true? Because when you calculate I modulo 10, you are subtracting from it 10 times something. You are subtracting from it a multiple of 10. I modulo 10 is always equal to I minus 10 times some k. By subtracting 10 minus some k, you are not changing its modulo 2. So I'm saying that if you are calculating I modulo some d, it's always equal to, if we first calculate I modulo some, let's instead of k use some x times d, and then calculate the results modulo d. This would be the same as I modulo d. Why these two are the same? Why I modulo d is equal to I modulo x times d modulo d? Because by calculating it modulo x d, you are subtracting some k times xd from it. This is a multiple of d as well as it's a multiple of xd. It's also a multiple of d. So basically we are not changing this number modulo d. It's going to be the same. So it's going to be the same as I modulo d. So I'm saying that when you calculate some I modulo some number, you can first calculate modulo some multiple of that number and then calculate modulo that number itself. This is a general fact. So this is a takeaway from this problem. I want you, while we're facing this problem, I want you to completely learn this as well. This is a number theory fact. This is a number theory fact that you should completely understand. So we're not only looking for solving this problem. I want you to also learn what we can learn from this problem. In general, I modulo d is always equal to I modulo some multiple of d, then modulo d. I don't want to just spit out the solution to you. I want you to learn this first. I want you to learn this fact. Okay? So this is always true. Is it now clear for everyone? If it's clear, please put a plus or use the 100 emoji, or if it's not, let me know. Nice. Thank you guys. Great. So it seems like for everyone it's clear. Awesome. Awesome. So, okay, so what can we say in here? Thank you. What can we say in here? We want to say that we want to find all the numbers like I from 0 to n such that I modulo 3 is equal to I modulo 5. We want to find all such numbers such that I modulo 3 is equal to I modulo 5. Basically, using that fact that I just talked about, I can say that instead of I modulo 3, I can write I modulo 15 modulo 3. And instead of I modulo 5, I can also write I modulo 15 modulo 5. So what I'm saying that the remainder of a number by 3 and by 5 only depends on its remainder by 15. So I'm saying that 0, 15, that's 0, 15, 30, 45, 60, 75, and so on. All of them have the same remainder by 3 and 5. They are both 1. And also 1, 16, 31, 46, they also have the same remainder by 3 and 5. I'm saying that if two numbers have the same remainder by 15, the remainder by 3 is the same and the remainder by 5 is the same as well. So I'm saying that the I modulo 3 is equal to I modulo 5 if and only if that is true for I modulo 15 as well. Okay, so I call a number good if I modulo 3 is equal to I modulo 5. I'm saying that I is good if and only if I modulo 15 is good. Okay, so that's the final takeaway. If we call those numbers good, let me see that in the statement, what are these numbers called? They haven't called anything. Let's say that a number is good if I modulo 3 is equal to I modulo 5. I'm saying that I is good if and only if I modulo 15 is good. So basically, if we can find out for every number from 0 to 14, we find out if they are good or not, we're gonna have that pattern repeated. Every 15 numbers, that pattern will be repeated. And we can see that even as we see in this statement, we can see that when n is equal to 15, it's given to you that only 0, 1, 2, and 15 are good numbers, that I modulo 3 is equal to I modulo 5. So from the numbers from 0 to 14, only 0, 1, and 2 are good numbers. So based on this, we said that it's enough to find out how many from, or let's say what numbers from 0 to 14 are good. And we know that they are 0, 1, and 2. And we know that, so 3 is not good, 4 is not good, and 14 is not good. So basically, a number is good if and only if modulo 15 is 0, or modulo 15 is 1, or modulo 15 is 2. So the good numbers are these numbers. 15k, 15k plus 1, and 15k plus 2. These are the good numbers that we will have. So we have to count such numbers: 15k, 15k plus 1, and 15k plus 2. Okay, that's basically what we have to do. And what is that? And how can we calculate what is this? It's only enough to say that for each n, I can first divide n by 15. I have n over 15, the floor of n over 15 complete blocks. Each of these complete blocks have 3 numbers. And also, if n modulo 15 was greater than or equal to 0, which it always is, but I'm just writing it to be consistent with the others. This always is true. But I'm just writing this way to be consistent with the other case. If n modulo 15 was greater than or equal to 0, it means that from the last block, there's one additional good number, so we add an additional number. If n modulo 15 was greater than or equal to 1, also we have to add one additional number. And if n modulo 15 was greater than or equal to 2, we add another additional number as well. So let's say that my number is 37. First of all, I say that the answer is 37 over 15 floor times 3, which is gonna be 2 times 3, which is gonna be 6. And then I see that n modulo 15 is greater than or equal to 0, so I add 1. Then I see that n modulo 15 is greater than or equal to 1, I add another 1. And then I see that n modulo 15 is greater than or equal to 2, add another 1. So it's gonna be 9. Okay, is it clear? Also, let's talk about an example as well. For example, this 42. I first divide 42 by 15. That's exactly like 37. It's 2 times 3, which is 6 plus 1 and 1 and 1, which is going to be 9. This 15 is going to be 15 over 15, which is 1 times 3, which is going to be 3. Plus 15 modulo 15 is 0. So the first case is going to be true. So plus an additional 1. But the other 2 ones will not be added. So it's going to be 4. Is it clear? Yes, I can repeat, sure. I can repeat. Kind of LCM, Chinese remainder theorem. Yeah. Okay, I repeat it very quickly from the beginning. I just tell you the general picture again. from the beginning. So, and I will answer this question very soon as well, just after explaining this. So let's see the overview of this problem again from the beginning. So basically what we are saying is this. We start from the beginning. We have I from 0 to n. Okay, we want to find out how many i's exist such that I modulo 3 is equal to I modulo 5. First, I said that I modulo 3 is equal to I modulo 15 modulo 3. Because when we want to calculate some number modulo some other number, first we can calculate it modulo some multiple of that number and then calculate the result modulo that number. And then therefore I said that I modulo 3 is equal to I modulo 5 if and only if that is true for I modulo 15. So I is good if and only if I modulo 15 is good. If I modulo 15 is good and its remainder by 3 and 5 are the same, then I is good as well. I's remainder by 3 and 5 are the same too. So basically we say that these two numbers have the same remainders if and only if for I modulo 15 those two numbers are gonna have the same remainder. And then I say that, okay, so then it's enough to find out that what numbers are good from 0 to 14. Because they are the possible remainders. I only calculate for the remainders from 0 to 14. I see that from 0 to 14, only 0, 1, and 2 are good numbers. Only 0, 1, and 2 are good numbers. So I'm saying that the good numbers are only going to be of form 15k, 15k plus 1, and 15k plus 2. These are the only good numbers. You can see that all the 15k's have remainder 0 to both 3 and 5. 15k plus 1s have remainder 1 to 3 and 5. 15k plus 2 have remainder 2 to 3 and 5. And then I say that first, when I get some n, first I see that what is the floor of division of n by 15. I have these many complete blocks with all remainders. For example, the first block is from 0 to 14. The second block is from 15 to 29. The third block is from 30 to 44, and so on. And I say that for each of these blocks we have 3 numbers, so we multiply it by 3, and plus also for n, if n modulo 15 is greater than or equal to 0, which always is, so always we have an additional 1 anyway, so we add 1. It means that the last block also has an additional number, because the last block is going to be till some point. So we have to see that what is n modulo 15 and see that how many of the first numbers it covers. If n modulo 15 was greater than or equal to 1, it means that there's also one number that modulo 15 is 1 in the last block. So we should add an additional 1. And if it was greater than or equal to 2, we should add an additional 1 again. For example, when the input is 15, you will first calculate 3 times 15 over 15 plus 15 modulo 15 is greater than or equal to 0, as always. So plus 1. But 15 modulo 15 is not greater than or equal to 1, so we will not add that. It's not greater than or equal to 2, we will not add that, so the answer is going to be only 4. Is it now completely clear? I hope that it makes sense completely. It also works that count is equal to n over 15 if n modulo 15 was less than 3 counts minus equal to 2 minus, and yeah, that also works, yeah. Okay, good. So we spent a lot of time on the first problem, but it's worth it. And guys, yeah, as you also mentioned, the chat is not subscribers only, and there's also a limit of, for now I set only 5 seconds between each two consecutive messages. For now it's like that. So basically I hope that this stops some of the spamming. So far it wasn't like that. It was very free. Anyone could send any message they want. But right now it's only subscribers and 5 seconds between each two messages. If by any case it's hard for someone to subscribe and for example it causes any issue for someone, you can tell me to remove that and just try to find some other way to stop spamming in the chats. But if you can subscribe, I would definitely be happy, and you can support my work as well by doing that, by subscribing to the channel and following the content. So tell me if anyone, if this was causing any troubles. I hope that it won't cause any problems, and everyone here are okay with that. Would you say that having AI makes my PhD work with duplicated elements count? What? I did everything else in the code master, I changed it. I didn't completely understand. Okay, so let's move on to the next problem. Problem B. Problem B, robot program. This problem is saying that there is a robot on the coordinate line. Initially, the robot is located at the point x not equal to 0, and the robot has a sequence of commands. Each command is either L or R, and L shows that it should go to left, R shows that it should go to right. The robot starts executing this sequence of commands. However, whenever the robot reaches the point 0, the counter of the executed commands is reset. So you will start executing commands from the beginning. And your task is to calculate that how many times the robot will enter the point 0 during the next k seconds. So this robot will keep executing the commands. Whenever it gets to point 0, everything gets reset. Something happens in robot's mind and it resets everything, and it starts executing from the beginning. And each second it does exactly one move. You have to say that after k moves, how many times it visits point 0. Well, my question is that, and we know that n is up to 2 times 10 to the 5th. And the sum of n over all test cases is up to 10 to the 5th as well. So my first question is that, what is the first time? What is the first time that this happens? That the robot reaches point 0. What is the first time? How can I answer this question? Let's make it a bit interactive. How can we answer this question first? What is the first time that the robot reaches point 0? Yes, I mean, these are exactly the ways that I'm attempting this problem in a contest. I mean, that's exactly the way. Why do you spend so much time on easy problems? Because the first problem, I usually don't spend that much problem on problem A, but I didn't want to I could just easily say that from the beginning that yes, the answer is 15k plus 1, 15k plus 2. That's it, calculate that. But the point is that had something to learn. Even if you have solved problem A, maybe you missed that. Maybe you missed that point, that important fact. So you needed to, even for the people who have solved it, it was necessary to emphasize on that fact. Yes, we can just brute force simulate. We can just move on. And see that what is the first time that we will be at point 0. So we can simulate. In this point, we can simulate. I try to make it a bit faster as well. Okay, if you guys want to go faster, I will try to go faster and also not missing any important thing. I will try to handle both in an optimal, this is an optimization problem. I will try to handle both. So we will simulate and find out what is the first time that we will get to point 0. If everything is done, if we could execute all the orders and we didn't go to 0, or the time has passed, we will just print 0 and that's all. We have not gotten to 0 before the time ends. Before our time. So in that case, we will just print 0. Otherwise, we see that how much it takes for us to get to 0. And then we subtract that from our time remaining. We see that how much time is remaining now. We subtract that much from our time remaining. And now we are at point 0. The point is that when we are at point 0, from now on, some pattern will continue. If I see that what is the next time that I will go to 0, because my start is from 0, and I'm gonna end at 0 as well, the next time the exact same pattern will repeat. And the next time again the exact same pattern will repeat. So the point is, when you start from point 0 and you get to 0 again and then commands reset, so the exact same pattern will happen as again. So for example, if you take a look at the first example, you have 2 minus 1 8, and you have L L R. RL. Sorry, that was RL. You start from minus 1. So the first time, first we see that what is the first time that we get to 0. That's time 1. In time 1 we get to 0 with the command R, and then everything resets. We subtract 1 from our time remaining, so it's going to be 7, and once we have seen point 0. And then from here, every time the same pattern will continue. For example, again, then everything starts from the beginning. I go R first, and then I have L, so I get back to 0. With spending 2 seconds, I get back to 0, and everything will reset. Again, I will go forward. The next time, I want to show you that the next time the exact same pattern will repeat. Exactly, again, I will go R first and then L. The next time, again, the same pattern, R and then L. The next time, the exact same pattern, R and L. So every 2 seconds from then, the same pattern will repeat, and I will go to 0 from 0. Because in all, the first time is different because you start from some other place. But from the second time, since you start from point 0, everything is going to be exactly the same. So you will see that what is the second time that you get to 0, and you see that how much it takes. And if it takes, for example, if your remaining time is k now, if from k you have subtracted the time that it takes for the first time to get to 0, for this, and then you see that it takes x seconds to go there for the second time, you can just see that what is k over x and add that to your answer. For example, in here, your remaining time is 7, and it takes 2 to get to 0 again. So you will see that what is 7 over 2? 7 over 2, the floor of 7 over 2 is 3, so you will add 3 to 1, and your answer is going to be 4. That's how you can calculate the answer. Yes, exactly. Your answer will be added by k over x if it takes x seconds from you to go back from 0 to 0. So first you see that you simulate. You see that from the first time, how much it takes for the first time to get to 0, and you subtract that from your k and add your answer by 1. And then you see that how much it takes for the second time to go from 0 to 0. And if it takes x and the total time is k, you will add k over x to your answer. And that's how you can calculate it. Thank you very much, Joyjit. Is there any algorithm to find this kind of cycles? Well, I mean, the first two problems have some similarity. If you look at the first two problems, you see that in both of them, there was some pattern repeating. So far it's like, it seems like they had the same author with the same mindset. In both of them, it was about finding the same pattern. In the first one, we had the pattern of 15 by 15 being repeated. In the second one, we had the pattern that once we get to 0, we can get to there again each time. So that's how we can see the same pattern. If it's clear, please put a plus or use this 100 emoji. And if it's not, also tell me to repeat it. And if you want me to, yes, I can show the implement. That was what I wanted to ask. So you said just at the same time. Love you from Iran. Thank you, Amin. My countryman. I spent too much time on finding the loop, but didn't get. But the point is that for finding the loop, you can simulate again. From 0, you can say that how much it takes from 0 to go to 0. If you never get to 0 again, then you won't see 0 anymore. But if you get to 0, you can see that how much it took. You have a 4 of length n for that. And then if you had that, that's all. You can get you can get the final answer by dividing k by x. Thank you very much, Sutanshu. Thank you. Speaking of which, from Iran, from India. Where are you guys from? Let's see if we are increasing our diversity or not. Thank you, Ayushman. At the same time, let me bring the code for the second problem, show you some implementation. Let's show you this C++. That one wasn't good. This one looks good. What is your country and your gender? Both are important considering diversity. India, 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 India. Bangladesh, India, India, Azerbaijan, Bangladesh, Iran, India, India, Ukraine, India, Bangladesh, Bangladesh, Syria, Indian male, Vietnam, male, India male, India male, India male, Bangladesh, USA, Bangalore, India male, Palestine, 23 male. Yeah, you can tell your age as a Dominican Republic male. My gender is Fenwick 3. Shout outs for Vietnam. Cool. Yeah, India is dominating. Definitely. Male, same team as tourist, considering it's from a gender war perspective. Antarctica. Where are all the women? That's really... Why CP doesn't have any females? That's really... That's really not right. You are from Iran, right? Yeah, I'm from Iran. Right now I'm in the US, but I'm from Iran. I'm studying here. I'm not a woman, but my mom is. Does that count? That was cool. How many of you, your mom is a woman? Females get job without CP. India of them, they are chilling, watching K-drama. No, these are sexist. Don't say those things. Let's be. We're trying to increase the diversity and make it more equal between everyone, all the countries, all the genders. So don't be sexist. We want to move on the other direction. Okay, sure. So I will move on to problem C. Let me show you this code as well, because you asked for the code as well. What does he do? Let's take a look at it. He starts a 4 from 1 to n. He's just basically simulating. And if s was equal to minus x and not of... Okay, so he's just adding up the numbers. If it becomes equal to minus x, he will just say that P0 is equal to I. So P0 means that the time that it takes to go from x to 0. So if the sum became equal to minus x, it means that if you start from x, you will go to 0. So P0, in 1/4, he will calculate that how much it takes to go from x to 0, and also he calculates how much it takes to go from 0 to 0. If s was 0, it means that you have done some operations and you're back to 0. I mean, the total, if you add up their fx on your position, they add up to 0. So if you start from 0, you will go back to 0. So you have P0 and you have P1. P0 is the first time, how much it takes for the first time to get to 0. P1 is how much it takes for the second time to get to 0. So P1 is that x that I was talking about. So if P0 was non-zero, if P0 was 0, the answer is 0. If P0 was non-zero, if Px was non-zero, if P1, sorry, why I say P8? If P1 was non-zero, was 0, the answer is gonna be 0 plus 1 is gonna be 1. Otherwise, it's gonna be k minus P0 over P1. So we subtract P0 from k and subtract it by P1. Is it clear? Thank you very much. Turkmenistan, good, new country. Move to C, stop other stuff. There should be a rating in future, name that. Thank you for being a explainer. There will be a rating. Thank you. Yes. Okay. Cool. So let's move on to problem C. Let's move on to problem C. Okay. So problem C, limited repainting. It says that you are given a strip consisting of n cells. All cells are initially colored red. In one operation, you can choose a segment of consecutive cells and paint them blue. Before painting, the chosen cells can be either red or blue. Note that it's not possible to paint them red. So basically, you have n cells, all of them are red. Each time you can choose an interval and make that interval blue. You cannot make anything red. You can just make them blue. And it says that it's clear that it is not possible to satisfy all requirements within k operations. Therefore, for each cell, you also have a penalty. The penalty that is specified for cell number I is equal to AI. The penalty for cell number I, if you do not set it as the color that it should be, is A sub I. The penalty of final painting is calculated as the maximum penalty among all cells. What is the minimum penalty of the final painting that can be achieved? So, and this is also an important point, that you are looking for maximum penalty. You want to minimize some maximum. It's a minimax problem. It's like you have some maximum that you want to minimize it. And this should remind you of something. Again, I don't want to just solve this problem. I want you to teach something important here. When we want to try to minimize some maximum, there's a trick that usually is used. What is that? What do you guess? What is the intuition? Yes, exactly. Binary search. Exactly. Binary search. When we want to minimize a maximum, usually binary search helps. Why? Because, when you minimize your maximum, you want to minimize your maximum. If you binary search your answer, it means that, basically, it means that all the numbers greater than something should be ignored. So, if you binary search like on X, if you want your answer to be X, it means that you should not have anything greater than X. Because if you have anything greater than X, your maximum will be greater than X. So if you want your answer to be at most X, it just means that you should ignore everything greater than X. It just means that you should ignore everything greater than X. Because if you choose anything greater than X, max is going to be greater than X, so your answer is going to be greater than X. But if all of the numbers that you have are less than or equal to X, it's okay. Your answer is also going to be less than or equal to X. So binary search makes everything very clear. So when you binary search on X, you will just say that, okay, ignore everything greater than X and just work with everything less than or equal to X. Okay. So for example, in this problem, we want to minimize the penalty, the maximum penalty. We want to binary search on our answer. Assume that we want to see if our answer can be less than or equal to X. What does it mean? It means that if for a cell, the penalty is greater than X, that cell definitely should not be penalized. That cell should definitely have that color. That cell must have that color that is specified. So basically what it means is that when you binary search on X and you say that you want your answer to be X, it means that for a cell, if the penalty for that cell is greater than X, definitely the maximum penalty is going to be greater than X as well if you get penalized for that cell. So you should not get penalized for that cell for sure. But for all the other cells, that their cost is less than or equal to X, it's okay. We can just set their color anything that we want. So it's like when you binary search, you're gonna have some cells that do not matter. You're free to set them as you want. And there are some cells that no, you're sure that they should be this color. So for some cells, you don't have any preference. For some cells, you want them to be red. For some cells, you want them to be blue. Okay, is it clear how binary search transforms this problem? So basically, when you binary search, you're sure that everything that is penalty is greater than X. Everything that is penalty is greater than X. It should have the color that it's supposed to. But for the cells which are less than X, for the cells that their penalty is less than or equal to X, they do not matter. They can be anything. We don't care if we get penalized. We want to just see that if we can make answer less than or equal to X, they won't mess with that. They won't stop that. Okay? Yes, sure. Binary search on the answer. Binary search on the final answer. Okay, let me explain it again. So I'm saying that let's take an example. Let's look at here and take an example. For example, on this one, the answer is 3. So I think it's good to consider this one. Let's say that we have 4, 1, BR. I will switch to tablets once after I wrote it. And 9, 5, 4, 3. This is what we have. BR. Let me write it above its cost. This is what we have. So I'm saying that, let's say that I want to see if the answer can be less than or equal to 4. If I want the answer to be less than or equal to 4, what does that mean? If I want the answer to be less than or equal to 4, it means that these cells do not matter. Their color can be anything. I don't care about them. These cells do not matter. Their color can be anything. But this cell and this cell, these two cells, 9 and 5, these two cells are critical. They should exactly have this color that they have here. Okay, they should have exactly the color that we have in here. So we want to see if we can make that or not. Well, basically, we can do that. We can, for example, only set this one to blue and keep the rest as red. And this works. These two do not matter, so we don't care about them. Only we care about these two. This is B and R, and that's okay. If I wanted the answer to be less than or equal to 3, now I want to check if the answer can be less than or equal to 3. Then this 4 matters too. Then we care about this 4 too. So this one must also be blue. Okay, if my answer is going to be less than or equal to 3, this one must be blue, this one must be red, and this one must be blue. Right? So can we do that or can we not do that? In here we can't do that. In here we can't do that. Why? In this example that I wrote, we can't do that. Because we have 2 blocks of B's, we need at least 2 operations to make this one B and to make this one B. It's not possible. Yes, I made a mistake while writing it. This is not possible. So in this case, the answer cannot be less than or equal to 3, but the answer is less than or equal to 4. So in this example, your final answer is going to be 4. But in their statements, the test case that they have is this one is 3 and this one is 4. So when I want to check if answer can be less than or equal to 3, this one doesn't matter. For this one I don't care. For this one it should be blue, for this one it should be red, for this one it should be red. So that's okay, I can do that. I just have one interval and I will just change that to blue. Okay. So when you do binary search, the point is that there is a subset of the elements that you don't care about their colors. There is a subset of the elements that you don't care about what is their colors. And for the rest, you want them to have the exact color that you're supposed to. But for some of them, you don't care about them anymore. Is it clear now what I'm talking about? I'm saying that if you want to just check if the answer is less than or equal to X or not, the point is that for all the cells that their cost is less than or equal to X, they are free. It's okay to pick them. It's okay to get penalized for them. I don't care, because they won't make the cost greater than X. Only for the cells with cost greater than X, those will be critical for me. I will only mind about them. Is it clear how by binary search everything will change? By binary search, the question will be equal to this. The new question is this. We have a tape. Each cell should either be blue or should be red or does not have any restriction. It can be anything. Can you make it like that or not? The free cells can be anything, but the blue cells should be blue, the red cells should be red. Is it clear? If it's clear, please put a plus or use this 100 emoji, and if it is not, let me know so that I will repeat it. Can we also do it using DP? We will talk about that afterwards. If we can also use another approach. How to do this question if sum of the penalty instead of max penalty? We can talk about that too. If the array for n. No, not n squared, like. I haven't told you the rest. I haven't told you the rest of the solution. So far, I'm just saying this. Okay. So now let's continue. Continue. Awesome. So everyone have understood this. Now I'm saying that, okay, so these are how the costs are specified. So now, next, what I will say is this. It's not possible that we have two operations, two intervals, such that they overlap. This never happens. Each time I know that I will make an interval blue. They never overlap. It doesn't make sense if they overlap. Or in other words, there always exists an optimal answer in which no two intervals overlap. So we can also restrict ourselves that all the intervals must not overlap. Because there exists such an answer, if the problem statement also restricts us that the intervals should not overlap, the final answer does not change. Because there always exists an optimal answer such that the intervals do not overlap. So basically, why is that true? Because assume that two of them overlap. Well, the point is that for the second one, either one of them is completely inside the other one, or they're like this. If one of them is completely in the other one, just let's delete this. Why you have this? If you have two intervals like this, you can, for the second one, you can start it from here instead of starting that from there. So basically, you can say that you can also consider this external approach. You can say that, okay, consider among all the optimal solutions, consider the optimal solution in which the sum of the intervals that you choose is minimal. In that one, you definitely don't have overlap, because I showed that you can decrease the number of cells that you will change their color. So basically, there exists a solution in which you only keep changing these joint intervals. So basically, everything looks like this. You will choose k different intervals, at most k different intervals, and you make them blue. So what is the only constraint that we must have? The point is that the number of blocks of B's should not be greater than k. The number of blocks of B's should not be greater than k. What do I mean by blocks of B's? I mean that if we have some adjacent B's, there are one block. And then we might have, for example, some reds, and then some blues, and again some reds, some blues. Like this. For example, in here, we have 4 blocks of blues. With k equal to 3, we cannot make them blue. Because, as we said, each interval can change, each of them can make one of them blue. Because if one of them tries to make 2 of them blue at the same time, the ones in the middle get blue as well. They shouldn't get blue. And do not forget that for now I'm considering the case where I know the color for each one of them. Why I wrote like this? I'm sorry for that. So anyway, the number of blocks should be less than or equal to k. That's the only condition. So when we have some additional question marks in the middle as well, that doesn't change anything. We can just ignore those question marks. So I'm saying that in the new question, as we said, we can just have some question marks in the middle as well, but we can just ignore them. This is exactly equivalent to BRR. So when you binary search, each of your elements is either B, which means that it must be blue, or it's R, which means that it must be red, or it's question mark, which means that this doesn't matter. This one doesn't matter that what it is. It means that its cost is less than or equal to X, so we don't care. And then you will just ignore all the question marks and you will have a string of B's and R's. And in this string, you will just check that how many blocks of B's do we have. And that's also very easy to calculate, that how many blocks of B's do we have. For example, in here we have 4 blocks of B's. How can we calculate that the number of blocks of B's is equal to the number of RBs that you see, plus if you consider that if you have one B at the beginning, you have to add 1 to it as well, plus nothing and B. Or you can add an imaginary R here and just calculate the number of RBs. The number of B's such that their previous element is not B is equal to the number of blocks that you have, because those B's starts another block. So the number of blocks of B's is equal to the number of B's such that their previous element is not a B. They start a new block. Okay, so you should basically see that how many blocks of B's do we have. If it's at most K, then we can make the answer at most X. If it's greater than K, we cannot make the answer at most X. Is it clear? Bro, go to D, please. Wait for C to be clear for everyone. If it's clear for you, please again put a plus or use that 100 emoji, or just if it's not, tell me that it's not clear. Can we sort the costs of blocks of B and block of R separately? We can also sort the blocks by their penalties and add them one by one and try to find the first time that the number of blocks passes over K. That also can work. That also works. That's how with sorting we can also calculate the answer by doing this. Yes, and the solution is O of n log n right now. How we would solve if it was minimum total penalty? If it was minimum total penalty, we would just make sure that the one with minimum total penalty, we pay penalty for that. I mean, if it was minimum, if you wanted to minimize the minimum total penalty, you should just calculate the minimum one, the minimum penalty, and make sure that you pay penalty for that one. That was how you could minimize the minimum. Actually, if it's red and AI greater than me, then we need to start a new segment. When you see another blue one, you should start a new segment to make them blue. Jiangli did by sorting. We can check Jiangli's code. Yeah, it works. But if it was some, I think DP would work better. DP of I and J was equal to the answer if you consider the first I element and you have used your kth interval. And you should have another dimension which was 0 and 1, which shows that the last one is red or blue. But in that case, n times k had to be small. So the constraints needed to be smaller. But if we wanted the sum, the n times k, we could do it with the dp of O of n times k. Hi Manas, how are you doing? Why not we just color only those k blue blocks having max penalties among all blue blocks? Those k blue, if we see that, because, well, the point is, there must be some reds in the middle of them, there might be some reds in the middle of them such that it merges two blocks. I mean, if there are between two blocks of B's, if there are some R's such that their penalties are low, we can just ignore them. I mean, when we are binary searching, they might be ignored because their penalty is low and we are willing to pay that penalty. And these two blocks would be merged into one block. If it was some of the bad elements, as I said, we could just do a DP of O of nk. Okay, sure, I will explain it again. No, the idea that I have in mind is O of nk. I will show you the code as well. 3e5 times log of it, yes, it works. Thank you, Manas, for your support. Sure thing. The rest that have penalty greater than means make a new segment if you have. Yes, that's also true. Except for the last one, I guess. Thank you, Shivash. I hope that it's helping you. So let me repeat this once again then, and then I will show you a code as well to make sure that it's completely clear for you guys. Can you give some tips on how to become 3-star on CodeChef? That's almost the same. I mean, CodeChef ratings are almost the same as Codeforces ratings, so you can just apply the equivalent on Codeforces. Thank you, Kush. What if k is something like 10 to the power of 4? Does O of nk work? It's gonna be 3e5 times 10 to the 4th. No, I think it's high. It's gonna be over the border, but I think that it gets time limits. And thank you, Manas, for supporting again. Yes, if you wanted to support, you can like the stream. Okay, so let's discuss it again. I also show you Jiangli's code as well, and you'll see that how did he do this. I will tell you the general picture again from the beginning. So basically what I was saying is that when we have a minimax problem, when we want to minimize the maximum of something, this is again something that you should take from this problem. This is important because you will face so many similar problems in the future that you want to minimize the maximum. And in most of them, when you see minimizing the maximum, binary search works great. Why? Because if you binary search on X, and for example on X, you want to see that if answer is less than or equal to X or answer is greater than X. In binary search, you choose some X and you want to just find out if your answer is less than or equal to X is in this part, or your answer is greater than X. Is your answer greater than X or less than or equal to X? And binary search simplifies these kind of problems a lot, because when you want to see if you can make the answer less than or equal to X, you are sure that everything that is greater than X, they should not happen. They should not be chosen. So what it means in this specific problem, in this specific example, it means that if you want your answer to be at most X, every cell with cost greater than X, they should not be ignored. They should have the exact same color. They should not be in our penalty. So basically in minimax problems, in the problems that you want to minimize some maximum, the point is that binary search works wonder. And for instance, in this problem, if you binary search, if for a cell the penalty is greater than X, that cell must have that color that is specified. That cell must have the specified color. But if a cell has penalty less than or equal to X, it doesn't matter at all if it's blue or red. I don't even look at what the problem wants the color for it. I don't even look at that. So if it's penalty, because all I want to answer is if the answer is less than or equal to X or if it's not. So if the penalty of some of them is less than or equal to x, I don't even look at the answer. In the future, I will consider them when I'm searching for smaller x's. But for now, I just want to find out if the answer can be less than or equal to x or not. So I will ignore everything. I will ignore everything that is less than or equal to x. So I start from the beginning. For everyone that its penalty is less than x, I will just ignore them. For the rest, I either have blue and red, and I will see that how many blocks of blues do we have, and if those blocks of blues was less than or equal to k, then it's possible to make them blue with k operations. Otherwise, it's not, because in one operation you should choose 2 of these blocks, and the reds between them get blue as well. So they will messed up. They will be messed up. So it won't work. Is it clear now? If it's still not clear, let me know. I will also show you a code so that it gets completely clear for everyone. Problem C code. You said, let's check Jungle code. If you've understood this solution completely, please put a plus or use this emoji, 100 emoji. If you haven't, let me know. And then I will show you the Jungle solution. About the transition, more detail for the DP solution for the sum version. If most of you want me to discuss that, I will discuss that. But if most of you want to move on to problem D, I will move on to problem D. Because that might take some time. But as I said, that case would be DP. If you want, I can discuss that, but that would make some time. And I'm afraid that we won't be able to solve all the problems. Okay, great. So let's look at this code. It says that, let's see what Youngly has done. I haven't seen this code before. I'm reading like it has a force in AIs. L of I is equal to I minus 1. Okay, he has made a linked list. Yes, this can work. This works. I think I understood what he's doing. He has made a linked list, and as I said, he will add everything. I haven't read the rest, but this is what I can say he has done. He will try to add them one by one from the most expensive one, from the one with the most cost, because that's the first priority, that we don't mess up with that. So he will sort all of them by their costs. And then he starts from the beginning and he adds to cost. He sorts them by their penalty. I mean, by cost, I meant their penalty. And he starts from the beginning and he says that cost plus equal to SI not equal to S of I minus 1. He counts that how many adjacent numbers are different. And then he has a for I on P, the elements based on their indices. And each time he will start ignoring the least important one, and he wants to find out if that makes the cost less than k. So each time, if cost was less than or equal to 2k, it means that we have less than or equal to k blue blocks. If the cost was less than or equal to 2k, it means that the number of blue blocks is at most k. So we will break in that case. And each time he's like removing the least important one, and it's like instead of doing binary search, he does this. He first we have BR. First, we have BR. So I'm telling you that how we can just instead of binary search, do this idea of sorting. He first makes this one, which has the smallest value, a question mark. And then he makes this one a question mark. And then he makes this one a question mark. So he sorts them based on their penalty. And each time he will choose the least important one and make that one question mark. If that fixed everything, that's the answer. If that hasn't still fixed everything, if still we cannot make that, he makes the next least important one a question mark. So that's basically what he's doing. Each time, instead of binary search, he iterates on the elements. That can also work. But binary search also works as well. The binary search idea always works, and it's very good to learn. But if you wanted to, on this specific problem, if you wanted to extend that a little bit, as I said, sorting can also work, but you don't need to confuse yourself with sorting as well. The main takeaway from that one was that binary search problem, binary search solution. If you know that the problem can be easier solved and everything else, this is just some bonus. The point is that on this specific problem, we can also start from the least important one and each time remove that. And when you remove that, you will decrease from the cost. I mean, if S of I is not equal to S of L sub I, that should be decreased from cost. If S of I is not equal to S of R sub I, that should also be decreased from the cost. And then you will add to cost S of L of I not equal to S of R of I. And then at the end, R of L of I is going to be equal to R of I, L of R of I is going to be equal to L of I. You have removed an element from your linked list. And as is equal to A sub I. And at the end, you will see out as. That's also how it works. You want to see the code of you can share your code for binary search as well if you want. Thank you very much, Kadesh, for your support. Also, guys, for supporting, I've made a website that you're not required to do anything for that website, but you can also check that website. But thank you very much. Let me add a heart here. I removed its link though from the description, the link of that website. Okay, so this is not my first, but yeah, this is the first one in a while. The last one was, I think, a few months ago. I haven't seen your question, I guess. Can you ask that again? I don't know what is your question, Raja. We can separate red and blue segments in different arrays, then we can apply DP. We don't separate, basically. I mean, that's ideal for if you are talking about some objective. If you're talking about some objective, yeah, we can use a DP, but we don't separate. We have DP of I and J, which means that we consider the first I elements, and the number of blocks of B that we have used is J, and we also have some Boolean dimension at the end, which means that the last element was red or blue. Can we use priority queue? We can use priority, guys, you don't need to send the message twice. I mean, it's okay. Especially with this much time difference. We can also use priority queue. Guys, all of these solutions are n log n. If you use a priority queue, if you use a binary search, if you sort them. Thank you, Kush. Thank you very much. Let me send the hearts here as well. Thank you very much, Kush. I cannot see my comments in the stream, no, but I can see your comments in this. You're not hidden. Anyone can see your comments now in the screen. And so if you want, you can share your code as well on binary search if you have used binary search. Shayan, give your super chat ID. I don't know what is my super chat ID. If you want that link, let me find that link. I removed that from the description, but it must be somewhere here. I'm opening another video of mine. Also, our dynamic programming topic stream has got 25,000 views. Let's see that when does it get to 100,000 views. You can send the links, so the links get removed. So this is the link for the supports if you want, but no, seriously, I don't expect anyone to support. I totally appreciate though for everyone who supported. Okay, so if you want, I can show you a binary search link as well, but I think we should very soon move on to the next problem because it's time to talk about the next problem. Let's look at this code. This code is very interesting and short. This code, what it's doing is that seeing all the CIs and then binary search each time. If CI was greater than mid and S of I minus 1 was equal to red, last is equal to 0. Let's see what does it mean. Why has he done that? If CI was greater than mid and S of I minus 1 is equal to B. So, okay, S of I minus 1 is the current one. You know, basically it's the current one. It's the current, because his 4 is from 1 to n. So this is if CI was greater than mid. So it means that this one is important. So basically if CI was less than mid, he could say continue. He's ignoring all of them. If C of I was greater than mid, if this one is red, S of I minus 1 is this one. It's not the previous one, it's this one. Because his 4 is from 1 to n, he uses I minus 1. If it was red, he will say that he has some variable LST that we will see what it does. He says it equal to 0. If it was blue, he will say that LST is a boolean, basically. When LST is 0, it means that the last one was red, or it means that the last one was not blue. Either we have nothing before, it's the first character, or the last one was red. So the last one is not blue, otherwise LST is 1, it means that the last one was blue. So he will each time subtract from nk LST equal to 0. Nk is your k. Nk should never get to a negative number. So he keeps that. Nk is the number of operations that he can use. Whenever he see that he has some b that its previous one was r, he will subtract 1 from it. And then at the end, if it was greater or equal to 0, r will be equal to mid. Otherwise, l is equal to mid. This is a very clean code. I really like this code. Let me share you the link to this code. Can you take personal classes? Guys, I have removed all these links from my from this video, and the first live stream that I've removed all of these links to make it less heavy. You're asking all these questions. Yes, I had also a website that's in which you can go and if you want reserve a personal tutoring with me. I do personal tutoring and I got that a lot in email, but it costs a lot, because in the US it costs a lot to do personal tutoring. So I guess that for most of the people over the world, even from my own country, from Iran, it's gonna be hard to afford that. But basically with the cost that I charge for tutoring is $100 per hour. This is the cost that I charge for 1 hour of class. So if you want, you can use that link, if in case you want to do that. It's me, and this is our photo in ICPC World Finals that didn't end up well at all. Okay. Why getting messages deleted? It seems that the messages with links wouldn't be sent. Okay guys, so shall we move on to problem D? You're already a millionaire. Are you talking with me? Or, I'm not already a millionaire, but I will hit that soon, hope. I'm working. I have some ideas. Okay, go to E, D, not E, D. So, problem D, 3 jumps. This problem says that you are given a rooted tree consisting of n vertices. The vertices in the tree are numbered from 1 to n, and the root is the vertex 1. Let d sub x be the distance, the number of edges on the shortest path from the root to vertex x. So d of x is the height of that vertex, and the sequence is like this. You have a chip at the beginning on the root. Each time you will move that chip to the next layer, to the next depth, but that vertex should not be a child of your current vertex. That vertex can be any vertex except your current, children of your current vertex. And you have to say that how many sequences do we have in general. We can do any number of moves that we want. We can even make 0 number of moves so that our sequence will be 1 at the end. For example, in this example, we can consider this example. I think this one is a better one. We have its picture here. For example, 1, 2, 7, 6 is an answer. 1 is here, 2, 7, 6. For the root, it's okay to go to any vertex on the next layer. I forgot to say that. For the roots, you can, because for the roots, all the vertices in the next layer are its children. So for the root, it's okay to go to any vertex. But for the rest of the vertices, you should not go to their children. And as you see here, from 2, you go to 7, which is not its children. And from 7, you go to 6. So 1, 2, 7, 6 is a valid sequence. And also 1 itself alone is a valid sequence. So let's see that. How can we calculate this? This problem is a dynamic programming on tree problem. We can use DP to solve this problem. Most of these problems that we have dynamic programming on a tree, these problems, it's very helpful to solve the problems like this. Consider the subtrees that you might have. The subtrees. For example, for each vertex, we consider the subtree of vertex v. And let's solve it for every subtree. For every subtree, for every vertex, we consider a subtree and see that what is the answer if we start from that one. Instead of starting from the roots, assume that we are starting from that one instead. Okay. So assume that. I didn't understand the question. Let me send you the link as well if you want. Sorry. You can take a look at the link. I'm saying it very quickly again. You have a tree. You start from the roots. Initially, you will go to one of your children, and the next time you can go each time to the next layer to any vertex except your own children. You can go to any vertex except your own children each time. You have to say that how many sequences you can make. Each time when you go on a vertex, you will write up its index. You have to say that how many sequences you can make at the end. So I'm saying that let's say we start from V. Let's say that our starting vertex is vertex V. What is the answer if we start from vertex V? It's not only the subtree as well. It's because in this problem, we can go out of subtree from a vertex V. We can go to the vertices out of the subtree. It's not only the subtree. We can go to any vertex below V. It's not only about the subtree. We can go to any vertex below the vertex V. So what can we say? Let's consider the next layer of vertex V. We want to see that if we were supposed to start from vertex V, if we were supposed to start from vertex V, how many sequences we can make? For example, in this one, let's say we start from 2. Let's say that we start from 2 in this one. One sequence that we can make is 2, 7. One sequence that we can make is 2 alone. And one sequence that we can make is 2, 7, 6. So we can make three possible answers starting from 2. Either 2 or 2, 7 or 2, 7, 6. So I want to find out the answer for all the vertices like this. So I say that let's take a look at the next layer. All the vertices that I have in the next layer. I can go to all of them except my own children. Except my own children that I cannot go to them. I can go to any one of them. And from each one of them, I know that how many sequences I have starting from there. From each one of them, I know that how many sequences I have starting from there. So if I just have the sum of the DPs of these, for example, if from V, my next vertex is U, the rest of the sequence has DP of U ways. The rest of the sequence is gonna have exactly DP of U ways. So basically it's like this DP of V will be the sum of all the DPs in the next layer which are not my own children. So for each layer, I can just calculate the sum of their DPs, sum of the DPs in this layer, and from that only subtract the DP of my children, because only those must be deleted. So I calculate the sum of the whole, and from that I only subtract my own children. And then my DP is gonna be that. Let's look at this example and see that what does it mean in this example. And also for the root, the answer is gonna be the sum of my children. And also, so my DP of V is gonna be the sum of DPs for vertices except the root, V greater than 1. It's gonna be the sum of DP of U's, where U is then in the next level, D of U equal to D of V plus 1, minus the sigma of D of U for every U that is child of V, U from children of V. So DP of V is going to be like this, sum of everything in the next layer minus the sum of the children. Also, you should add an additional 1 as well, because you can make an additional case as well by just considering V itself and not anything else. You can also consider V itself, and that's also one case that we only have V in our sequence and we don't expand it. So if we don't expand it, it's V itself. Otherwise, we can just fix that what is the next vertex that we will go to. So by doing this, and as I said, for the root, it's just DP of V is just DP of sum of DP of children. Sum of DP of, let's say, only 1 is going to be the sum of U for children of 1, DP of U, and at the end plus 1. So let's see it in an example. Let's start from here. We start from the last vertex, from the vertices in the lowest height. So we run a DFS. Whenever we want to get back from the DFS, we will calculate the DP of that vertex. First, we calculate the DP of the children of that vertex, and then when we wanted to get back from this vertex, we will calculate the DP of itself. So before DP of each vertex, the DP of the vertices, it's not DFS, sorry, it's BFS, like, because all the vertices in the next layer must be calculated. So basically what we do is this. We start from the latest, from the last vertex, because in here all the edges, we know that parent of I is less than I. So we can simply have a 4 from n to 1 and calculate the DPs. We have a 4 from n to 1 and calculate the DPs in that order. This way we can calculate from bottom and go up. Or not exactly, sorry. It's not like that. Let's do a BFS, calculate the heights and start from the end and go backwards. Sorry guys that I changed it. Let's just sort them by their heights and go backwards. For example, in here, first I calculate DP of 6, and then I calculate DP of 3 and 4 and 7, and then 2 and 5, and then 1. Sorry that I changed it so much, because this last one that I was saying had some bug. Is it clear? Should I build help us in company online assessments? I can do that. You can email me. That looks interesting. Yes, we can do level order. We will do level order. Exactly. Going from n to 1 has some bug that you can see even in this example as well. Before 7, 6 must be calculated. So it's not, you cannot go from n to 1. We should go level based. Start from the last level and go forward. And how does the DP will be calculated? For 6, it does not have any vertices in the next layer. So that sum is going to be 0. We only add 1 at the end to it here. So it's going to be 1. Then for 3 and 4 and 7, we can have them in any order. For 3, the sum of the next layer is 1. The sum of its children is 0. And plus 1. So dp of 3 is going to be 2. For 4, the sum of the next layer is 1. The sum of its children is 1. And we add another 1 to it as well always. So it's going to be 2 as well. For 3, the sum of the next layer is 1. The sum of the children is 0. And we should add an additional 1. So it's going to be 2. Why I wrote 2 here? Sorry guys. It's 1. And then for this 2, the sum of the next layer is 5. The sum of its children is 3. And we should always add an additional 1. So dp of 2 will be 3. And we saw that dp of 2 is 3 before. It's giving us the answer that we expected. For this one, for 5, the sum of the next layer is 5. The sum of its children is 2. And we should add an additional 1 always. So it's going to be 4. And for 1, we should sum up its children, which is 7, and add an additional 1, which is going to be 8. So this is how this dp will be calculated. So the answer must be 8. Now let's see if it's really 8 or not. And we see that it's really 8. So basically, we calculated this dp. Let's scroll a bit. We were calculating this dp, and we started from the one in the last layer. Each time, the value of each vertex is the sum of the vertices in the next layer minus the sum of the children plus 1. And this way you calculate everything only for the root is the sum of the children plus 1. And this way with dp, this problem will be easily solved. Why adding 1? We will add 1 because it's also possible to have a sequence with only that element. For example, for 2, we're calculating the sum of the next layer minus the sum of the children. So basically it's dp of 7. Because if we go to the next layer, we should go to 7 definitely. But it's also possible that we have a sequence only consisting of this node. So that additional 1 that we always have is the case where we don't have any next node. We will start here and end here. We have only one vertex. Is it clear? That additional 1 is for the case that we have only one vertex. For example, for this one, that additional 1 is that if we only have 1 and nothing else. So we should add 1 to each one of them to keep count of the cases where we have only one element. Educational rounds are really easy than normal div2 because it's based on standard problems. We want to reshred someday current progress. Depth count. What do you mean by depth count? I didn't completely understand this. How count of level plus or minus edge of I? Not minus edge of I dot size. Minus the sum of the children. See, look at this. We are saying that our next vertex must be the next vertex that we have. Must be not the child of V, vertex V. So we say that if we need to calculate the sum of the dp's of the vertices which are not children of V. So we should sum up the dp's of all the vertices. As I said, let's calculate the sum of all the vertices in the next layer. This is this blue part, this green part. And then subtract from that this blue part, the sum of the children. This way you can calculate the sum of all the dp's in the next layer which are not your own children. Okay, you are calculating the sum of all the dp's in the next layer which are not your own children. And that way you will have them and add an additional 1 because there's also possible that you won't go to any of them. You will end in this exact vertex. Is it clear now? Sure, I will explain again. Hello from free stream. Top layer to bottom will be easier to implement, right? We can maintain adjacency list when do level order traversal and update like sum of all previous layer minus parent. Yes, that's also true. That's also true, but that's way we must sum up all the vertices. Yes, that also works, I guess. This DP also works. Let me explain this DP as well. Let's see how it works. The suggestion is this: start from top layer and go downward. And first DP of 1 is 1. Let's calculate that. Instead of saying that starting from this one, how many sequences do we have? Let's talk about how many sequences do we have that end on this one. For example, we have exactly one sequence that ends at 1. And then for each one of them, for 2 and 5, it's also 1, because whatever that is from 1 can go to 2 and 5. It's because they're the children of root, their value is equal to the value of root. It's 1. And then for each vertex, it's gonna be the sum of the previous layer minus its own parents. Because you can go to this vertex, for example, you can go to this vertex 3 from any vertex in the previous layer except your own parents. So it's gonna be the sum of the previous layer minus your parents, your parents. So it's gonna be 2 minus 1, which is gonna be 1. For 4, it's gonna be again 2 minus 1, which is gonna be 1. For 7 again, it's gonna be 2 minus 1, which is 1. And for 6, it's gonna be 3 minus 2. Which is 1 as well. Sorry, why I said minus 2? 3 minus 1. Because your parent, your vertex 4 is your parent, and that's the only vertex that you can not come to 6 from that. You can come from 7 to 6 or from 3 to 6. So you should add up DP of 7 and 3. Or in other words, you should add up all the vertices in the previous layer except your own parents. So this is always, this is your parents, which is 2. And at the end, your answer is going to be the sum of all the numbers. So basically, we are saying that there is one sequence that ends with 1, one sequence that ends with 2, and so on. Only for 6, there are 2 sequences that end with 6. And let's check that out. My laptop is running slow. As you see, there's exactly one sequence that ends with 1, one sequence that ends with 2, one sequence that ends with 7, one sequence that ends with 5, and so on. Only for 6, there are 2 sequences that end with 6. So these DPs are exactly accurate. DP of each vertex is gonna be accurately the sum of what they should be. For 6 is 2, and for the rest of them are 1. And it should be the sum of the previous layer minus your parents. And you could also do a BFS for this. For this one, you can also do a BFS to calculate this. This is an interesting problem. I like this problem. This was very cool. I liked how DP problems, combinatorics problems, they're always beautiful. As you see, my laptop is not working well. Let's see what can I do to make it work better. Guys, I cannot see you now. I hope that you can see and hear me though. I'm trying to make the burden lower on my system. Wait. I feel kind of guilty because this laptop was really a good laptop and I had such a heavy use that it's facing this kind of issues. It's really, this is the result of keeping 100 tabs open for ever. Sorry guys if I cannot still see your messages, but still I hope that I'm not disconnected and you guys at least can see and hear me. Okay, can you guys see and hear me now? I'm back. I mean, you're back for me. I hope that I haven't gone anywhere to be back. Can you see me guys and hear me? Okay, you could. And I can see from here too if you could see me. This, yes, you were seeing me. Good. Okay, nice. I kind of ruined this laptop. I feel guilty. I had such a heavy use, and guys, always try to close your tabs, especially. Don't keep them open. Free up your space. This is my advice to you. Don't ruin your laptop. Okay, so was it completely clear that what I said about problem D, this second solution was even better than the first one? If it was, use this emoji or put a plus or say that. If it's not, let me know to say it again. Do you want me to show you a code as well or not? I didn't completely understand this question, as I said. I don't know what does it mean 0D times 1D times 2D minus 1D, child. But I don't think that you can show the answer with product of some numbers. Yes, great. Second version was way better. I liked it too. I liked it very much. Don't help in online assessment, he's basically asking you. Oh, online assessment. Okay, so, okay. That was something else. Thank you very much that you said this. I had another thing in my mind that he wants me to help to assess, not helping him to be assessed. Yes, that definitely I won't do that. I was assuming that he wants my help to assess someone. That was interesting, but this is not interesting. Okay. Show you submissions or not. Moving on to the next problem. Please explain for I equal to 2 to n, and of I is equal to count of nodes level of I. Plus 1 minus edge of minus edge of I dot size does not work, because edge of I dot size is the number of children, but we're not looking for the number of children. We are looking for the sum of their DPs. So we will subtract their sum of their children from them. So basically your answer is gonna be either, if we go downward, it's gonna be the sum of everything in the next layer minus your own children. If we go, if we look upward, it's gonna be the sum of everything in the previous layer and subtract your parent from it. Expected rating of problem D. I think 1600 or 1700 might be good. What do you guys think? I think 1600 or 1700 might be good. Okay, let's move on to the next problem, problem E. Game with binary strings. Guys, also if you wanted me to show you codes, let me know. Because I assume that you don't want that. If you want to talk about that, let me know. Create group for company assessment discussion. By discussion, do you mean cheating or what? If you're looking for cheating, we can't do that. Or I don't know what sort of discussion. If it's really discussion, like discussion can be okay. Discussion is good. But it depends on for what purpose. I can do that, and if it was being misused, I can close that. But yeah, I can do that. Yes, code please. Okay, sure. I will show you the code. One of you send me your code. If you want me to show you your code, you can send it again. But okay, let's first show you the code because you asked for that. Let's again use this code. Well, basically what he's doing is, yes. So basically what he does is this. First he has a DFS that calculates the heights and he pushes back those vertices into their own height. This DFS only does that. He calculates the heights and pushes back to their own height, each vertex their own height. And in here, he will find out all the adjacent vertices, and basically what he's doing, dp of 1 is initially 1 for each other vertex. For each height, he does this. For each height, he does this. He will have a 4 on all the vertices of that height, and he will say that he will sum up the vertices in that height. He will sum up the dp of those vertices in that height. And then this is where he's calculating the sum. Then what he's doing, then he's having a 4 on all the children of that vertex. And basically, this if, he didn't need this if because he's just pushing back the children. So even without this if, it would work. dp of k, dp of this child, is gonna be dp of k minus dp of j plus mod. So it says that he will subtract the dp of parent from its child. He's basically, what he's doing is that he is subtracting the dp of the parent from its child. And at the end, he will add to all vertices in the next layer this value of s. dp of k is 0 in here. So basically in here he's doing this. He's making it minus dp of j. And then at the end, he will add the sum of everything to the vertices in the next layer. So basically, he's doing this dp that goes downward. He looks at all the vertices in the previous layer, he sums them up, their dp's up, and then he will just subtract the dp of your own parents. That's all. Okay, cool. Yeah, I showed another code though. Sorry about that. No, not at all for cheating. Good. Okay. How much money you get from CF? I don't get any money from CF. So let's move on to the next problem. Yeah, I think problem D was very beautiful and I liked it. And for me also, it looked easier. Let me see that what C was about. I forgot it for a second. Okay, yes. I also, because D was more structured and beautiful, etc. Right? So that's basically what I'm thinking about. Okay, so let's talk about the next problem. This is the last problem that I've read and we will discuss today. We will not discuss F. I just want to make sure that something is right. So let me check a code. My conjecture, I mean, that is something that I feel that is correct. And it's that the number of zeros, if it's greater than or equal to 3 times the number of ones plus 2, then the first player can win. Otherwise, the second player wins. But let's see if that's true. He's calculate, yeah, that's basically what he's doing. Plus 1 minus 3. And f of 0 is 3 times n. He's done it in a weird way though. Oh my god, what is this? I'm not sure what are they doing. Q of v equal to 3 times n is equal to 1. If s of I was 0, plus v minus 2 v minus 2 c minus. Oh, it's cool. It's cool. Yes, that he's basically doing the same thing. I think they are all doing the same thing that I said. Basically, if we have k ones, we should have 3k plus 2, at least 3k plus 2 zeros. If editorial is out, we can check out the editorial as well. Has anyone also done the same approach? I just want to make sure about it before talking about the solution. I don't know. I will talk about that. But has anyone done the same thing? I mean, what's the solution that I had in mind was that if the number of ones is k, the number of zeros must be 3k plus 2 at least. About my source of income, I'm doing a lot of things. So basically, maybe it's not the good point to talk about this. Let's talk about that later. So did any of you guys solve it with the same way or not? My friend did with BIT. No, the solution that I'm thinking about is way easier. Okay, let me tell you the solution. It's correct because this code basically done the same thing. Yes, this code is basically doing the same thing. Let me tell you about this solution and this very beautiful shortcode. Okay, guys, we talk about the proof. If there was any issue, we'll find in the meantime as well. But it's correct. I mean, I just haven't implemented it. So let's talk about it. Let's discuss it, and at the end I will show this beautiful code to you as well. So basically, problem E, game with binary string. It says that consider the following game. 2 players have a binary string and the players take turns. The first player makes the first turn. During a player's turn, he or she has to choose exactly 2 adjacent elements of the string and remove them. The first player has to remove 2 adjacent zeros. The second one, among those 2 numbers, one of them at least must be 1. So for the first player, both should be 0. For the second one, one of them at least should be 1. You have to say that if both players play optimally, who will win the game? And each time you are given you have to say that also the first character and the last character are adjacent as well. So the characters are like around the circle. You have to say that if you have a binary string S, for how many substrings of S, player 1 will win the game. So you have to say that for how many substrings. Player one will win the game. Is the statement clear, or do you need, I mean, I explained this statement in a bad way, but if you understood it, I can move on to the solution, because you might have already read it. So is the statement okay? Is the problem statement okay? My game theory isn't probably strong enough to solve E. You can watch the game theory topic stream, although I don't think this one is that much like game theory, like grounding numbers, etc. It's not that much game theory. So what am I saying? I'm saying that the first player will win if and only if the number of zeros will be greater than or equal to 3 times the number of ones plus 2. That's what I say. If the number of zeros, or I can show it with n of 0. If n of 0 is greater than or equal to n of 3 times n of 1 plus 2, player 1 will win the game. Why? There are several things that I have to say. The first fact, we go fact by fact. Fact number 1. Player 2 in his own turn always chooses a 1 and a 0. I mean, because player 2 does not need to remove two consecutive ones. He can always choose a 1 and a 0, and this will remove one of the zeros, because zeros are so valuable for the first player. Zeros are so valuable for the first player. So as long as there's some zero, it's better for the first player to change something to 1 0, remove some 1 0 and keep a 1 and instead remove a 0. Unless all of them are 1. If all of them are 1, it's obvious that player 2 will win the game, if all of them are 1. Otherwise, if it's not obvious that he will win yet, he will always choose 1 0. He will never choose 1 1. Okay, is it clear so far? Do you guys agree with this? Yes, sure, I will explain the logic. So I'm saying that firstly, what I say is that always player 2 will remove 1 0. Okay, player 1 will always remove a 1 and a 0 first. Is it clear? This is the first fact. I don't know if I said player 1 or player 2. Player 2 will always remove 1 0. Player 1 will always remove 0 0. Okay, so cool, good. So that's the first thing that we say. And then by saying that each time player 1 removes 2 zeros and player 2 removes a 1 and a 0. Now assume that n is less than 3k plus 2. By continuing this process each time, player 1 make a move, then player 2 make a move. Player 1 make a move, then player 2 make a move. The number of zeros will be each time subtracted by 3. The number of ones will be subtracted by 1. So it's like next time we have n minus 4 n0. N0. Assume that n0 is less than 3 times n1 plus 2. Next time we will have n0 minus 3 less than 3 n minus 1 plus 2. And that's also true, but from both sides 3 will be subtracted. So if this is true, always it remains true as well. If the player 2 keeps this strategy, always the number of zeros will remain less than 3 times k plus 2. 3 times the number of zeros will always remain less than or equal to 3 times the number of ones plus 2. So basically the strategy for second player is going to be this. Each time after player 2 chooses 2 zeros and delete them, player number 2 will choose a 1 and a 0 and delete those 2. That's how he works. And at the end they will stop. The point is that when they stop, when they cannot make a move anymore, I want to show you that it's player number 1 who is not able to make a move. I want to show you that it's player number 1 who is not able to make a move. Because if player 1 makes a move, he will subtract the number of zeros by 2. Okay, so he will subtract the number of zeros by 2 by doing that. And n0 is less than 3 and 1 plus 2. So he will subtract the number of zeros by 2. So after that, n0 will also be less than equal to 3 times n1. So for any zeros that we have at least 3 ones remaining. So in that case, we have a 1 remained for player 2 to do the last action and choose a 1-0. So basically, thank you, Shotan Shu. Basically, what I'm saying is that if we keep doing this, it is gonna be always after player 1's move, player 2 can make a move as well. It's not possible that player 2 cannot make a move, because each time, the only way that he cannot make a move is that when n1 becomes 0. But this does not happen because n0 is less than 3 n1. So n1 must be at least 1. Okay, n0 is less than 3 times n1. So n1 cannot be 0. It must be at least 1. Okay. So therefore, what we can say is that player 2 will win the game in this case. Is it clear? Let me just check something out to make sure that everything is completely okay. So far, guys, are you guys okay with that? As at the same time that I'm thinking, you please respond if you're okay with that. So the problem is problem E of the contest. So n times that 0, 1 goes and n times 0, 0 goes. Yes. So total 3 n zeros, we need 2 more at, yes, exactly. Exactly, that's right. At the end, we need 2 more for the first player to win. Although I'm thinking about something as well. I'm thinking about one thing that I'm not sure about. For example, if the final string is 0, 0, 1, the first player can win the game. If the final answer is 0, 0, 1. If the string is 0, 0, 1. Because the first player takes out 0, 0 and the 1 will remain. I'm just thinking about that. But 0, 0, 0, 1, in the case of 0, 0, 0, 1, the player 2 will win. So I'm thinking about maybe the odd case and even case must be handled separately. So I think that there's something that we should say. There's something that we should change. There's a small thing that we should change to just fix it. Did you guys understand what was the issue? Let me write it in the chat. Assume that we have 0, 0, 1. In this case, if we have 0, 0, 1, the first player will win. Although n0 is less than 3 times n1 plus 1. So I'm thinking that only in this case, that n0 is equal to 3 times n1 minus 1, again player 1 will win. Only in this case. This one is an additional case. Yes, that's only this case. Okay, great. So we have a corner case. And this is the only case that doesn't work. Why? Okay, so I'm saying that if n is less than 3n1 plus 2 and n0 is not equal to 3n1 minus 1. This case is a special case that again player 1 will win. If this happens, I show you that player 1 cannot win. Player 2 will win for sure in this case. Why? Because if we keep doing that, assume that at some points player 2 loses the game. I know that each time we will lose 3 zeros and 1 1. We will lose 3 zeros, 1 1, 3 zeros, 1 1. Okay, so that's what is happening. Each time we are losing 3 zeros and 1 1. Assume that now, we know that at the end still n0 is less than 3n1 plus 2. Assume that player 1 has done his operation, so he has removed 2 zeros. So now n0 is less than 3n1. So the point is that n1 must be at least 1 if n0 is not equal to 3n1 minus 1. So it means that it's not possible that right now n0, the only bad case in here is that if we only have 1 1. If we only have 1 1 remaining, that's the only case that player 2 can lose the game. And in that case, you can see that n0 was 3n1 minus 1. Because in the last operation, n0 was 2 and n1 was 1. And now these two are removed. Only 1 and 1 is remains. So you can see that always it's like this, the 2 and 0, 1, 1. So it's like the number of zeros is 3 times 1 minus 1. If it's not like that, so definitely player 2 can make a move as well, because we have at least 1, 1 and we have an additional element as well, which can be 0 or 1. So we can delete this too. So it's a contradiction that player 1 cannot make a move. So in this case, player 2 will win the game. So player 2 wins. Player 2 wins if and only if n is less than n0 is less than 3n1 plus 2 and n0 not equal to 3n1 minus 1. Is this clear? So we needed an additional argument as well. n0 must not be equal to 3n1 minus 1. If it's completely clear, please put a plus or use emojis or say something in the chat. If it's not, also let me know. So basically what I'm saying is that n0 must be equal to 3n1 minus 1, must not be 3n1 minus 1, and it should be less than 3n1 plus 2. One more case, if we have 0, 0, 1, 0, 1, you should remove the last and first element. We are always considering that it's the first player turn first. Okay, so if it's player 2 turn right now, it means that previously we had 2 additional zeros too. So we had 5 zeros and 2 1s in that case. Okay, we had 5 zeros and 2 1s in that case. So in that case, the number of zeros was equal to 3 times the number of 1s minus 1. Man, I'm talking about a solution. Let me at least finalize this. And guys, I have to leave like in 5 minutes, so we have to end it soon. Let's talk about it soon. Is it clear, guys? So I'm saying that, let me explain it again. n0 is less than 3n1 plus 2 and n0 is not equal to 3n1. In this case, player 2 will win the game because each time 3 zeros and 1 will be removed, and at the end I know that there will be, in each of the turns of player 1, there will be at least 1 1 left. Because after each move of player 2, after each move of player 1, 3 times 1 is more than the number of zeros. So always when it's turn of player 2, there is a 1 remaining. And also we can say that at the end, if there's another element as well, he can make a move, otherwise he cannot make a move. Okay, you're welcome, SKMDRF. How should we come up with that formula? I will tell you about this. No, let's say player 1 is done, and that is a string was. Yes, let's say that player 1 is done. Okay, if player 1 is done and this is the string that is remaining, player 2 can make a move. I'm saying that always after player 1's move, player 2 can make a move in this case. Because always after player 1's move, there is a 1 left. So if there's 1 additional element left as well, player 2 can make a move, which is a contradiction. So the only case is that. No, let's say player 1 is done and that is a string what remain at that point. What do you mean that player 1 is done? You mean that player 1 has removed 2 zeros before that, right? So for better, initially we have 0, 0, 0, 0, 1, 0, 1. Okay, this case P1 removed. Okay, sure. In this case, we see that, as I said, that's exactly what I said. We have 5 zeros and we have 2 1s. So the number of zeros is equal to 3 times the number of 1s minus 1. So this is a case that player 1 wins. So because it's this case, n0 is equal to 3 and 1 minus 1. I told you that in this case player 1 will. So in this case player 1 wins. Sure, no problem. But thank you for mentioning this example. In this case, player 1 will win the game. Okay. Now I should tell you that in the other cases, player 2 will win the game. In this case, we saw that. In other case, player 1 will win the game. We said that in the case when n0 is equal to 3 and 1 minus 1, we talked about why player 1 will win the game. Because they keep reducing this, and at the end, player 2 will be left with only 1, 1, and he can't do anything with that. In the other case, where n0 is at least 3 and 1 plus 2, each time 3, 1, there's an OR between these two. Each time, 3 zeros will be removed and 1, 1. 3 zeros, 1, 1. 3 zeros, 1, 1. At the end, there will be at least 2 zeros left. So player 1 can always make a move. When all the ones are removed, still player 1 can make a move. So that's the question. We have to find out that how many substrings do we have such that n0 is greater than or equal to 3 and 1 plus 2. For which, what should we use for this in order to count such intervals? What should we use in order to calculate that? And also let me tell you that the intuition behind this formula is this. The point is that only the number of zeros and ones matter. If you look at it, I mean, how did I make up with this? How did I come up with this? I said that whenever there is an action that player 2 can make, it's always better for him to choose a 1, 0. It's always better for him to choose a 1, 0. Remove a 1 and a 0. It's not beneficial for him to choose a 1, 1. If he does that, if he chooses a 1, 1, he's removing 2 1s, and zeros are very valuable for the other player. It's better for him to remove one of those zeros. So if you see this, it's like after each 2 turns, 3 zeros are removed, 1, 1 is removed. 3 zeros are removed, 1, 1 is removed. It's problem E. 3 zeros is removed, 1, 1 is removed each time. So if at the end, at least 2 zeros will be remaining, player 1 will win the game. So if n is greater than n0 is greater than 3 times n1 plus 2, player 1 will win the game, definitely. Also, if n0 is equal to 3 times n1 minus 1, in that case also player 1 will win, because if you keep repeating this action, at the end you will end up with 1 1 only with 1 1, and in that case player 2 cannot do anything with that. So that's how we can do it, and for which we can use prefix sums, as we talked before. I mean, we talked so many times about prefix sums, and you can see the video that I made for prefix sum as well, in case you're not very okay with prefix sums. You can find it in the channel somewhere in here. Prefix sums. You can see it here. I talked a lot about prefix sum in that one, and I talked about all the cases that prefix sum has. We can use prefix sum. So basically we start from the beginning and calculate the prefix sums. Let me show you this code. He's basically calculating prefix sums. The only thing is that he starts, instead of 0, he starts from 3 times n. Why does he start from 3 times n and not from 0? The reason is that he doesn't want the number to get negative. So he starts from 3n, such that even if it subtracted n times, still it will remain positive. It remains non-negative. So he starts from 3n to keep the number non-negative. And each time as you look at it, if he sees a 0, he will add 1 to v. v is the current prefix sum. He adds 1 to v. Otherwise he will subtract 3 from v. Now for it's like for each 0 we have a positive 1. For each 1 we have a negative 3. Now if you look at an interval, if instead of each 0 we put a positive 1, and instead of each 1 we put a negative 3, basically what does this formula mean? It means that the sum of here should be either at least 2, because this is exactly n0 minus 3n1. It must be either at least 2 or it must be equal to minus 1. So these are the only cases. This sum here should be exactly equal to minus 1, or it should be at least 2. Because when you put plus 1 instead of each 0 and minus 3 instead of each 1, when you sum these numbers up, you basically have n0 minus 3 and 1 in that interval. And if it's minus 1 or it's greater or equal to 2, it's a good segment. Otherwise, it's not a good interval. So basically, he's doing that. And he's also t of I says that how many prefixes have their prefix sum equal to I exactly. T of I is that how many prefixes have their prefix sum equal to I exactly. Okay. So in the beginning, you see that t of v equal to 3n. He set it equal to 1. It was 0, now it's 1. The empty prefix. And then each time you see that when he updates something, he will update that t as well. I mean, at the end, he will say that t of v plus plus. So he will add 1 to the number of prefixes with that prefix sum. And also he will c is the sum of all the prefix sums greater than or equal to sum of all the prefixes, such that if they match with the suffix, sum of all the prefixes, such that if they match with the suffix, their sum will be at least 2. The sum of that prefix will be at most 2. So each time you should, if your prefix sum right now is v, you have this prefix and its sum is v. The point is that the sum of your prefix that you will delete must be at most v minus 2, such that there will be at least 2 left here. So the sum of this prefix must be at most v minus 2, such that there will be at least 2 left here. So that's why he's trying to calculate the sum of the number of prefixes, such that their prefix sum is at most v minus 2. So each time when he will increase v, he will add t of plus plus v minus 2 to his c. When he wants to decrease v, he will first decrease v by 1 and subtract t of this v minus 2 and then subtract this v minus 2 and subtract this v minus 2. So basically your value of c has all the prefixes, the number of prefixes, such that their prefix sum is at most v minus 2. So it gives you all the intervals that end here and their sum is at least 2. And also he adds t of v plus 1 to it. This is all the intervals that their sum is minus 1. And then he will update t of v. And at the end he will see out ends. And that's how the answer will be calculated. That's all. This way he will calculate the number of intervals such that their sum is either at least 2 or is at minus 1. Is it clear? If it's completely clear, please put a plus or use this emoji. If it's not, put a minus or tell me what didn't you understand. I understood decrementing v 3 times. What's happening subtracting t of v minus 2 3 times from c? Well, these are different v's. Instead of subtracting v by 3, he will subtract it one by one. For example, if your v is 13, first he will subtract it by 1, and in here he is subtracting from c t of 11. And then he will subtract t of 10 here because now v is 12. V in here subtracted by 1. So in here he will subtract t of 10 and then he will subtract v by 1 again. So v will be 11. And then in here he will subtract t of 9 and then subtract v by 1 again. It will be 10. So basically, while he's moving from 13 to 10, he will move one by one, and each time he's subtracting from c the t of that one. So these are different ones. This is t of 11, this is t of 10, this is t of 9. T of 11 is for 13, t of 10 is subtracted because of 10, t of 9 is subtracted because of 11. So it's cool. Is it clear what I said? I'm a bit late, guys. If I don't leave very soon, I will lose my head because I have to do something and I'm running out of time. I have a deadline. So if it's clear, let me know. If anything is not clear, also let me know. I just got back. What problem are you on? I'm on problem E. And this is the last problem that we talk about. Head. Okay, sure. I won't lose my head. Did you need PVDS? What is PVDS? What do you mean by PVDS? I saw some didn't have it. Do you mean prefix sums or something else? I don't know what is PVDs. Order statistic tree. No. We don't use that at all. See, it's just this little cute code. I mean, nothing complicated. That's just this little cute code and nothing else. That's all. Yeah. You didn't need that. I see. Yes. Okay. Yeah, probably. Okay, guys, thank you for joining. Don't forget to participate in the votes in the Telegram channel. I'm creating the greatest course on DP and it will be ready very soon. My income sources are different, varies. I do teaching and I study PhD, so I get funds from the university as well. University also pays me. And also I do some other things that I'm basically learning and I earn nothing from them right now. But if they work, I can make a lot of money on them because they're gonna change so many things. So I'm basically helping some startup. I'm working in a startup. So basically right now I'm not making anything, but I can talk more about it in the future. How long do you think it would take for an average person to become an expert in CF if they just started CP? I just talked about it in my last video on From Newbie to Expert in 3 months. I told you that what did I do to get to expert in 3 months and what you can do as well. So I really recommend it to you. I wanted to listen solution of only C and I'm here. Cool. That's great. Yeah, maybe in future I will explain that. Right now I have to leave, but yeah. I will talk about that too. Yeah, that's great. That's great that it attracted you to stay in here. Awesome. Thank you guys for being so wonderful and supportive. That's great. I hope to see you again very soon. Probably I see you guys tomorrow with another contest discussion, and also I will put the votes for the next topic stream in the Telegram channel today. So choose what topic you want to discuss there. Thank you guys. Goodbye. See you next time.